Okay, so let's say you have data from two different data sets and you want to compare them. And the most famous one is you take applied with me, you get maybe like an 80%, or you take applied with Miss Yosik and you get a 70%. Someone else gets 70%, and the one that gets 80 can brag like, hey, I got higher than you, right? My mark is higher than you. But it's actually not fair, right? Because there were maybe different standards, different ways of marking, whatnot. So z-scores are what actually allows you to make a fair comparison. Okay, so this is what we're gonna do. Jay's final score in his class is 70%. The class average is 75. Standard deviation is 5%. Okay, so this is gonna be Jay on this side. Jasmine's is 60%. The average is 65. Standard deviation is 7. Okay, so let's try this real quick. I tried to make these lines, I tried to make a bit thicker lines every once in a while. Okay, so these are five wide if you do this correctly. So let's go with Jay's average first. The average for Jay's class is 75, and the standard deviation is 5. So we would go 80, 85, 90. Then go down 5, right? 70, 65, 60. Let's draw a bell curve. Which of the two bell curves is going to be steeper? Jay's or Jasmine's? What does standard deviation mean? Average distance from each point to the middle. And if you have a smaller standard deviation, your points are closer to the middle. So this one is going to be steeper. Okay? Steeper because it's got lower standard deviation. Remember that. That's something I would expect you to. So this one is going to be slightly steeper. We go from there. Okay. And where's Jay on this thing? What's Jay's actual mark? 70. Jay, if we could pinpoint that, Jay is right there. Which, by the way, Jay is below the average, right? Below average. I don't think that's a surprise. Because 75, right, and 70. Let's go with Jasmine here. Let's find the middle. And we're also going to go by 5s here. So this would be the average for Jasmine's class is 60. And there's a standard deviation of 7, correct? So watch what we're going to do. We're going to go 7 this way and put a mark here, which is 58. Then we're going to take 7 away. So 1, 2, 3, 4, 5, 6, 7. This is 51. And then 1, 2, 3, 4, 5, 6, 7. Over here would be the next one, which is 44. And we go up by 7. Sorry, I got this wrong, right? The average is 65. Can we put a 65 in here? Just so you know, the other numbers are fine. I did not make a mistake here. I just made a mistake on the 65. It's supposed to be 65. If we add 7 going to the right, you go 5, 6, 7 right here. This is 72. 1, 2, 3, 4, 5, 6, 7. That would be 79. 1, 2, 3, 4, 5, 6, 7. I'm just increasing this a little bit. That would get me to 86%. This bell curve will be a little flatter. Jasmine's mark is 60, right? So 60, if you think about it, this is 65, this is 58, 60 is right here. Both of them, both of their scores are below the average for their respective classes. Okay. Highlight the fact that we've created two normal distribution curves for each of their classes. And now we're going to put them both on the same curve. And we're going to do that by figuring out the z-scores for each student. So Jay's z-score and Jasmine's z-score. So that's fairly simple. Z would be x minus x bar divided by standard deviation. This would be -1. No problem, no problem, anytime. -5/7 is -0.71. Thank you very much. Thank you. Okay, so what have we done now? We've standardized, we've put them both on the same bell curve. Okay, this is a standard normal distribution. Add the word standard in front of normal, where the mean is 0 and the standard deviation is 1. Okay? So you go to 0, you make a dot at the top and then just taper it off to both sides. And now let's place them on the standard normal distribution. Where is J? J is right here. Where is Jasmine? This would be 0.8, so 0.71 is right about here. Jasmine's z-score is slightly up on the x-axis, closer to 0. So in this case, who did better overall? Who really did better? Jasmine. Okay, Jasmine did better in this case. So you want to be very careful to not always pick the one that's higher up the x-axis as the winner, but Jasmine did better overall, since her z-score is greater than J's. Oops, you can't see that. Let me zoom in. Okay. So that is what z-scores can also do for us. It allows us to truly compare, put everybody on the same playing field in that case. Can I give you some examples for this? Housing prices. Manitoba has lower housing prices than Toronto. If you want to go buy a house in Toronto, I'm going to tell you this, it's going to be very, very hard for you to ever be able to afford a house in Toronto with just any job. Like, you're going to have to make some decent coin, okay? But incomes are also higher on average, higher in Toronto than Winnipeg, right? So we're like, well, comparatively, is it truly more expensive to buy in Toronto than Winnipeg? If you compare, we would have to do the Z-score calculation. We would have to look at the average income for Manitoba, average income for Toronto, and figure out which one is actually more expensive to afford, like which one is more affordable. So that's where Z-scores comes in. And so you gotta kind of keep that in mind. Z-scores allow us to kind of put everything on the same playing field and get rid of the additional bias that may exist, okay? That's that for this.